Welcome back to Mr. Hassan's Maths channel. I'm now going to answer question number 8 from the exam practice from Pure Mathematics P3 from the textbook. This is like an exam at the end of the textbook. And question number 8 here is, it looks very much like it's a P4 type of question, like partial fractions. But in fact, because they gave us the form in which it can be written, this could be considered as a P3 question. Okay. However, trying to attempt to do this by algebraic long division will get you into a bit of a muddle, because you'll end up with something like ax plus b, and then you'll have your remainder as like something like cx plus d over x squared minus 4x plus 4. Okay, so you'll end up with something like this: x squared minus 4x plus 4, and you might be able to factorize this to x minus 2 squared. But then to make this go to look like something like that requires us to understand partial fractions in P4, right? So attempting to do this by algebraic long division will give you something of this form, all right, which if you don't know P4, you wouldn't really know how to go from here to here. So, you know, this question is kind of designed as if it's a P3 question, for you to do by comparing coefficients, which many students don't like to do. But because of that reason, I'm going to go through it by comparing coefficients. So what I'm going to do first is I'm going to rewrite this as 3x cubed minus 10x squared plus 8x plus 1. And I'm going to factorize the denominator here. So it becomes x minus 2 squared, because that's a perfect square. When you factorize, you get x minus 2 times x minus 2. And I'm going to write this as it is. So this is identical to ax plus b plus c over x minus 2 plus d over x minus 2 squared. Now what I'm going to do is I'm going to multiply both sides of this identity by x minus 2 all squared, in which case this side will just be 3x cubed minus 10x squared plus 8x plus 1. And here I'm going to multiply this whole bracket, or make this into like one term, one bracket, times x minus 2 squared plus, and if you multiply x minus 2 squared with this, one of the x minus 2's will cancel out, so I'll have c times x minus 2. If I multiply this x minus 2 squared with this, it's just going to become d, because x minus 2 squared will cancel out top and bottom. So now what I'm going to do is I'm going to look at my x cubed terms. I'm going to compare them. On the left side, I have 3. On the right side, I'm going to have the only x cubed terms will be ax cubed, because this will be x squared times ax, which is ax cubed, so it's going to be a. So we can see pretty clearly it's going to be 3. All right, so a is equal to 3. Okay, so that's the value of a here. And then for the next thing that's easiest for us to look at is the constant. It's always the constant and the highest power that's easiest to find. So here we got 1 on this side. On this side, well, you're going to end up with b times minus 2 squared. So it's going to be b times 4, which is 4b. And here you're going to have minus 2c. And then you're going to have plus d. So that didn't really help us much, because we don't have any of those, right? Those always will be constants. But that might help us later on. Then we're going to I'll go to the x squared terms. Okay, and here on this side we have minus 10. On this side, the x squared term. Now, if you think about it, this is going to be x squared when I square it. So we'll have bx squared. So I've got b. And when I do ax times, let's see, that's going to be, this will be x squared minus 4x plus 4, just to make it a bit clearer. When I do ax times the 4, that's also going to give me an x term, so it's going to be plus a. That'll be x squared term. Okay, and when I do b, I've already done the b, right? Bx squared. So ax times this minus 4, sorry. It'll be ax times this minus 4. ax plus b, you have to just be a bit careful here. That will be x cubed, that will be the x squared. So it'll be minus 4a. and that will give me an x term. That will give me a b. That will give me an x squared term. That's right. Yeah. So it's going to be just these two. So I know what a is already. I know it's 3. So I can go on to find out what b is. I have minus 10 is equal to b minus 4 times 3. So minus 10 equals b minus 12. So therefore b is equal to minus 10 plus 12, which is going to be 2. So I have b equals 2 and a equals 3. All right, and if we compare the x's now, on this side we have 8. On this side we have, well, if we expand this, you're going to have 4 times a. That'll be one of the x terms, and the other one will be minus 4 times b. And if I expand this, I'll have plus c, and that'll be it, right? Okay, so I know what a and b is. I can find what c is now. So I've got a, 8 equals 4 times a, so it's 4 times 3 minus 4 times b, so 4 times 2 plus c. So this gives me 8 equals 12 minus 8 plus c, so 8 equals 4 plus c, so c is equal to 8 minus 4, so c is equal to 4. So I've got c equals 4. So I have A, B, C, and now I can find what D is. I can use this, what I use for the constants. So I have 1 equals 4 times 2 minus 2 times 4 plus D. So 1 equals 8 minus 8 plus D. So D is equal to 1. So now we can write everything as it is. We have AX plus b plus c over x minus 2 plus d over x minus 2 squared. So we've got a as 3. So we have 3x plus, and b is equal to 2 plus c, which is 4 over x minus 2 plus 1 over x minus 2 all squared. And there we have our answer. We have now written this in the form that's required. Okay, so as I said, if we this is a bit of a long-winded method, this comparing coefficients, but it's good to know it. In this particular case, as I said, if we try to do long division, we would end up with a problem, and I'll show you that problem. I'll show you over here what happens when you try to do long division. It works out fine. But when you don't know how, if you don't know about how to deal with partial fractions, you won't know how to deal with what we have to make it look like what we have in the end. So here, for example, you're going to get 3x, and that will be 3x squared minus 12x, sorry, 3x cubed minus 12x squared plus 12x, and then when you subtract these, that gives you minus 10 minus 12, which is 2x squared. 8 minus 12, which is minus 4x, and plus 1. Again, x squared into 2x goes plus 2. So there we got our 3x and our 3 and our 2 from A and our B. We got that already. That gives you 2x squared minus 8x plus 8. Now, when you subtract these, okay, when you subtract these, this becomes 0. This becomes minus 4x plus 8x, which is 4x, and 1 minus 8, which is minus 7. So we end up with something like this. Okay, if we look at it, we have 3x plus 2, which is fine. But then you have plus 4x minus 7, which is the remainder over this. Minus 4x plus 4. Now, how does that become this? Well, we factorize that. You have 4x minus 7 over x minus 2 squared. So how does this become this? That's what we have to understand. Partial fractions in P4. So that's about as far as you can go. And how do you make it become this? Well, that's something, as I said, for P4, right? So that's P4 material for us to use long division and to get further from this to this. That's why here the best, or the way that's related to P3 in answering this question is to use, set up an identity as I've done here, and then use recognition. Okay, we could have done things in another way. I could have, for example, substitute x equals 2 into all of this and that, and I could have found d straight away, because these both would become 0. And then if I put 2 here, that's 3 times 8, 24 minus 10 times 4, 10 times 4, 40. That's going to be 16 plus 16 plus 1. That will give you 1. D equals 1 is what we found, yes. We would have been able to get rid of those, but the A, B, and C, we wouldn't be able to find them in any other way except for comparing coefficients anyway. All right, so that's how to answer question 8. Many people prefer to use long division. In most cases, I'd say 99% of the cases it would work perfectly fine. In this case, because we don't know how to go from here to here, unless we've studied partial fractions in P4, the long division kind of stops at this point. We can't put it into this form without having that further understanding. So therefore, using this comparing coefficients and identities is what works if we're going to stick to P3 stuff in this question. Okay, so I hope that was clear. Other questions from this particular exam practice paper can be found in the playlist that will appear over here. Other questions from P3 algebraic fractions will be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video that will show here that will teach you how to use my channel effectively. Thank you for watching, and see you soon.